Hello students, welcome to mathematics class. See, now today we discuss partial fractions. Before starting the partial fraction, I will tell you the definition of rational fractions. Okay. Everyone know that the meaning of rational. Rational number is form of what it is p by q, where q is not equal to 0. The rational function is also in the form of f of x divided by g of x. Condition g of x not equal to 0. Such type of fraction we call it as rational fraction. Okay, and here f of x and g of x are polynomial functions. Okay, next, after knowing the rational fraction, what is the definition of rational function? A number of a function is in the form of f of x divided by g of x. Condition g of x is not equal to 0. Such type of fraction we call it as rational fraction. And here f of x and g of x are polynomial functions. Okay, after knowing this, now I will take proper and improper fractions. Proper and improper fractions. Proper and improper fractions. Okay. For proper and improper fractions, very first step is definition of proper, later improper. If consider the example x plus 1 by x square plus 1, x plus 2 by x cube plus 3. Just see the example. Here the variable x, its power is what? 1. Here the variable x, its power is 2. If the degree of the numerator, just concentrate, if the degree of the numerator is less than the denominator, if the degree of numerator is less than denominator. See, here also degree of numerator is less than denominator. Such type of fraction we call it as proper fraction. Okay, such type of fraction we call it as proper fraction. Next example I will take x square plus 2 divided by x plus 1, x cube plus 1 divided by x square. Okay, here degree of numerator. Degree of numerator is greater than degree of denominator. Degree of numerator is greater than denominator. Such type of fractions we call it as improper. Please remember that. Improper fractions. Okay. Proper fraction means numerator, degree of numerator is less than the denominator, we call it as proper. Improper is if the degree of numerator is greater than the denominator. Such type of fraction we call it as improper fraction. And for solving the examples, remember that always if it is an improper fraction, we have to convert in terms of proper, then only we can do the example. This is the definitions of rational functions, proper and improper fractions. Okay, after doing this, first just I am giving the introduction part of what? The definitions of rational, proper, improper. After knowing this, now I will take another example. With example I will give the explanation. See, 3 by x plus 3. 3 by x. Example is 2 by x plus 3 plus 1 by x minus 2. 1 by x minus 2. See, just concentrate this rational fraction and this rational fraction. Here, degree of the numerator. See, here x is not there. Means if it is not there, means it is x to the power 0. Correct? Here, degree of the numerator is less than denominator. Here also, degree of the numerator is less than denominator. Means here, these two are what? Proper. These two are proper fractions and their sum it is given. Correct? Take the LCM. What will it is? X plus 3, x minus 2. and 2 into x minus 2 plus 1 into x plus 3. Do the simplification. You will get the answer is in the form of 3x minus 1 divided by x square plus x minus 6. Correct. Here we expressed sum of two proper fractions. Sum of two proper fractions. Sum of two proper fractions. Sum of two proper fractions as a single proper fractions. Just concentrate. What we consider two proper fractions, we have done sum. Again it is a proper only. See, the power of x is here 1, the power of x is 2, means degree of the numerator is less than the denominator. We know that the definition of proper is what? If the degree of the numerator is less than the denominator, such type of fraction we call it as what? Proper. Therefore here we expressed sum of two proper fraction as a single proper fraction. The reverse process of expressing a single proper fraction as the sum of two or more proper fractions. Sum of two or more proper fractions. Sum of two or more proper fractions is called what is known as partial fractions. Is called partial fractions. What we have done? We consider two proper fractions. We have done sum. The reverse process means the proper fraction can be written as sum of two or more proper fractions. Single proper fraction can be converted in terms of two or more proper fractions. Such type of fractions we call it as partial fractions. For this we consider 2 and 1 is there, no? These two are constant. To calculate that 2 and 1 we are taking this A, B, C like that. Okay, this is what the definition of partial fractions. Okay, after knowing the definition of partial fractions, now I will give the condition. For the proper fractions or rules of a proper fraction. Rules of a proper fractions into a partial fractions. Okay. First rule. Denominator containing non-repeated linear factors. Denominator containing non-repeated linear factors. For example, I will take, just concentrate here, I will take the example is in the form of 1 divided by x minus 1, x minus 2, x minus 3. I will take. Please concentrate here. See here the degree of the numerator 1 is there. 1 means we can write this x to the power 0. X to the power 0 is 1. See here multiply the issue, you get what it is, x cube. Is the degree of numerator less than the denominator? Of course. Therefore such type of fraction we call it as proper. If it is proper fraction, we can convert it in the form of partial fractions. Okay. See how many number of factors are there exist here? 3 factors. And just concentrate. This is x minus 1, this is x minus 2, x minus 3. All the linear factors are different. Means non-repeated. They are not repeated. 1, 2, 3. They are different. If they are different, we can write this one is in the form of, just concentrate, a by x minus 1 plus b by x minus 2 plus c by x minus 3. This is how we can express. Understood or not? If it is a non-repeated linear factors, if the factors are not repeated, then these factors we can write a by x minus 1, b by x minus 2, c by x minus 3. For example, if I take 1 divided by x plus 1, x plus 2, right? These two are also non-repeated, but how many number of factors are exist? 2 factors. Therefore, we consider 2 constants. Here, 3 factors are there. Therefore, we consider 3 constants. We have to calculate later onwards. But now here, how many number of factors? 2 factors. We can write this one as a by x plus 1, b by x plus 2. Therefore, the single proper fraction can be converted in terms of sum of 2 or more proper fractions. Such type of fractions we call it as partial fractions. For example, I will take another one. 1 divided by x plus 1, x plus 2, x plus 3, correct, x plus 4. Okay. How many number of linear factors are exist? 4. But all the 4s are different. Therefore, we can write this one. A by x plus 1, b by x plus 2, c by x plus 3, correct, d by x plus 4. This is how we can apply the what if denominator containing non-repeated linear factors. This is the condition. Okay. And the non-repeated linear factors are if it is in the form of x plus a, x plus b dash dash dash. In that case, we can write 1 divided by x plus a, x plus b can be written as a by x plus a plus b by x plus b dash dash dash. Okay. If what? Non-repeated linear factors. If 2 linear factors are there, we are taking 2 constant, 3 constant, 4. Okay. Next. Next, second condition. If denominator containing repeated linear factors. Repeated linear factors. In this case, how to solve the example? For example, I will take 1 divided by x minus 2 the whole square. See, how many number of roots are exist here? 2 roots, but that 2 roots are similar roots. Repeated roots are exist. In this case, we are writing how many number of roots are exist? 2 roots. Therefore, we have to take 2 constants, and this can be written as a divided by x minus 2 plus b by x minus 2 square. This is the rule or condition if roots are repeated. For example, I will take another one. 1 divided by x minus 2 the cube. Means how to write this one as? How many number of roots are exist? 3 roots. Therefore, 3 constants exist. A by x minus 2. Okay. Next, b by x minus 2 square. Next, c by x minus 2 the. Okay. For example, if I take another one, 1 divided by x minus 2 to the power 4, and we get how many number of roots exist? 4. Therefore, we can write this one as a by x minus 2, b by x minus 2 square plus c by x minus 2 cube. See, 1 root d by x minus 2 to the power. Okay, if roots are repeated. If roots are repeated. Okay. For example, if I take 1 divided by x minus a the whole square, repeated linear factor, this can be written as a by x minus a plus b by x minus a the square. For example, another one I will take 1 divided by x plus 1 x minus 2 the whole square. Means this is one root is repeated, another one is different. Means we can express this one is in the form of which one is different? This one. We can write this one as a by x plus 1. How many number of roots? It is 3 root. Then next remaining we can write this one as b by x minus 2, c by x minus 2 the. Okay. For example, another one I will take 1 divided by x plus 1 x minus 2 x minus 3 square. Means here only 2 roots are repeated, these two are different. Means we are applying the combination of repeated as well as non-repeated. Therefore, we can write this one as a by x plus 1 plus b by x minus 2 c by, these two are repeated, therefore we can write x minus 3 d by x minus 3 the. This is the combination of repeated and non-repeated mixture. Okay, next last one rule is there. If denominator contain non-factorizable quadratic quadratic factor. Non-factorizable quadratic factor. In this case, this is 1 divided by ax square plus bx plus c. Or else I will take another one example. 1 divided by x square plus 1. This is, if it is in the form of non-factorizable, means we can't easily do the calculate the factor. See, x square plus 1 if I apply 0, what we get? X square equal to minus 1. X is what? Plus or minus root minus 1. That one is not belongs to real number. Therefore, if root does not exist easily, in this case, the condition is in the form of, just concentrate, how many number of roots exist? 2 roots. Therefore, this can be written as, we consider 2 constants, but it is can be written in the form of ax plus b divided by x square plus 1. This form. We are writing this one in the form of ax plus b by x square plus 1. For example, another one I will take, just concentrate, 1 divided by, I will take x minus 1, x plus 1 the whole square, x square plus 1. Means this is a combination of non-repeated, repeated and non-factorizable. In this case, see, this is non-repeated, one root exists, therefore a by x minus 1. This is repeated, we can write how many number of roots exist? 2 roots, and this can be written as b by x plus 1, c by x plus 1 the whole square. And this is non-factorizable quadratic factor. And if it is non-factorizable quadratic factor, this is in the form of like this. Means how many number of constants exist? 2 constants. That 2 constants we can write dx plus e. Instead of a and b, we consider d divided by x square plus. In this way, we can write. These are the rules of partial fractions. Please remember that the rules. If you know the rules, then only we can do the examples. Such type of examples, the rules remember, and based on that, such type of examples are usually asked in the exam for 3 marks. Next class I will give the example.